All right, the last one in this unit, 7.4. Graphing reciprocal functions. Now, reciprocal functions are really quite easy. You take the numerator and the denominator and just do, what with them? Flip them. Does the sign change? No. The sign does not change. So if it's negative, it stays negative. If it's positive, it stays positive. Okay. Now, here's the question. What we're going to do is we're going to graph y equals x and y equals 1 over x. Right? That f of x just means x. It's whatever the value is. Right? So y equals x. You should be able to graph that without even thinking about it. Right? So what we're going to do is we're going to create a little chart on the left-hand side, just so you can see what it's going to look like when we do all this. So the chart is going to be, it's going to take up most of that little space there. At the top, we're going to have x. We're going to have y, which equals x, and we're going to have y equals 1 over x. Okay. That's our x value. That's our y value. That's the reciprocal. So that's the first one is our x value. The second one's our y value. That's our reciprocal. You need 2 points, an x and a y, to be able to plot it on the graph, right? You need an x and a y. Okay. So we're going to make a little chart here. So let's do this. Probably need a little more. Yeah, this keeps going on here. Oop. Horrible line. Yeah, it doesn't have to be straight. We're just going to do this. Okay. Now, this is a standard grid, which means it's negative 10 to positive 10, both x and y, right? Negative 10 to positive 10. So we're going to use those numbers. So let's pretend x is negative 10. Okay? If x is negative 10, what's y? Negative 10. It's really quite easy, right? That won't change. You're welcome. If x is, what did I do in here? Negative 5. If x is negative 5, what's y? Negative 5. Oh, that's easy. If x is negative 2. Negative 2. If x is negative 1. Negative 1. If x is 0. Oh, that's easy. 1. 2. 5. I guess I didn't need as much space on this one, did I? Oh, actually, hang on. Did you do that? Hopefully you did that in pencil. Did you do that in pencil? No. Oh, you should always be doing this in pencil. I want some fractions in here. Hang on, I want some fractions in here. Oh, just listen. I want some fractions in here. What did we do there? Negative 5, negative 2, negative 1, negative a half. Oops. Where's my board way off again? I want some fractions in here. Negative 1, negative a half, negative 1/5, 0. Okay, so I want those two fractions in there. And then a fifth and a half underneath that, a fifth and a half. Okay, what's negative 2? What's y? Negative 2. Okay, thank you. What's negative 1? What's the y? Negative 1. What's negative a half? What's the y? Negative half. Negative a fifth. 0. What about 1/5? What is it? 1/5. 1/2. What's our next number after that? 1, 2, 5, and 10. Those are our numbers, right? So what do you notice about the x and the 1? They're the same. So can we graph this? What's it going to look like? A line, yes. A line through the where? Origin. Up 1 over 1, up 1 over 1, up 1 over 1, right? So it's a perfect line. Hang on, let's draw this. Give me a sec here because it takes me a minute to line this up sometimes. Of course. Yeah, I would always do it in pencil. Now, if you look, we can plot some of these points on here, right? That was one of them at the origin, right? Is that correct? 1, 1, 2, 2, 5, 5, 10, 10, right? We can plot these points on here. It's really, that one's really quite easy to do. 1, 2, 3, 4. Sorry, what? Okay, so where would negative a fifth be? Well, it would be somewhere along that line, right? So is that one easy? Is that easy to do? Now let's do the reciprocals. Basically all you do is you take the x and the y and you flip them. Okay? So let's see. Let's start with the negative 10. You got negative 10. You flip it, it becomes negative 1/10. Oh, okay, well that one's not too difficult. Negative 1/10. You take negative 5 and you flip it. You end up with negative 1/5. You take negative 2 and you flip it. Negative half. See what we're doing here? Careful here. Oh, this one is really tricky. Negative 1. Flip. Negative 1. Does it change? No, that one's kind of nice. Okay, now you'll see why in a sec why I put in negative a half here. Negative a half, you flip it, becomes negative 2. Negative 1/5 flips. Negative 5. Zero flips. What's this 0 over, by the way? This first 0. It's over 1, right? It's 0 over 1, is that correct? When you flip 0 over 1, it now becomes 1 over 0, which is what? Not possible. We refer to it as not undefined, right? Undefined. Oh, ooh, undefined. That's going to be a little bit hard to graph, isn't it? How the heck are we going to graph an undefined? No, we'll find out in a minute. Okay. 1/5 reciprocal. 5 1/2 reciprocal. 2 1 reciprocal. 1 2 reciprocal. A half. 5 reciprocal. 1/5 and a 10 reciprocal. Okay. Those are weird numbers. Do you think we can graph them though? We can try. Okay, let's start with, should we try this first one? Negative 10, which is to the left. Negative 1/10, which is where? That one's a little bit hard to graph. Let's just leave that one alone for a sec. Okay. Which one do you think we should try to graph first? What do you think of this? Let's try negative 1. That's not bad. Well, that's interesting that, look at that line there. Negative 1, x and y is exactly the same as negative 1, the reciprocal, right? So it's exactly the same point on both graphs. Something useful to know there. I'll do this one in red so you can see it, see the difference between this. No, let's do it in blue. Yeah, let's do it in blue. So this point right here, and this point right here, obviously, because it's going to be 1 and 1, right, are exactly the same point on both graphs. Okay. What else we got here that we can do? Well, that one wasn't bad. So 1 and 1. Let's try this one. Negative a half and negative 2. So negative a half is going to be right here. And negative 2 is going to be right there. Well, that one's not bad to graph, eh? Right about there. Is that pretty close? Yeah, a little bit trickier to graph. Well, let's do the flip side of that. If it was a half, then it'd also be, what was it down lower? A half and 2. We can graph that one. 1/2 and 2. Kind of looks like a mirror image, doesn't it, so far? I'm graphing the reciprocals. That's what's in blue here. Let's try this next one. Negative 1/5 and negative 5. Okay, so negative 1/5 is really close to the x-axis, isn't it? But 5 is way down. 1, 2, 3, 4. Right about there. Isn't that about there? Is that correct? Look at these 3 dots. What are they doing as they go down? They're getting closer to the x-axis. Oh, that's kind of cool. Kind of neat to know. So if that was negative 1/5, negative 5, what about 1/5? What about 1/5? And 5. Okay, so what do you notice about this side? Oh, that's a horrible placement, isn't it? It's getting closer to which one? The x-axis is coming from the other side, though, isn't it? Okay. Well, that's neat. You will in a minute. Okay, so let's try these guys. We're going to ignore this one that's 0, 0. We're going to leave that right to last because I want to make a point. So which ones did we forget about? These first three, right? The negative 10, the negative 5, and the negative 2. We forgot about those ones. So let's do them now. Oh boy, let's try this one. Negative 10. Sorry, what? No, we didn't. So negative 10 and negative 1/10. So negative 10 is way over on the left here, and negative 1/10. Where is it close to? The y-axis. Is it almost right on it? Yeah, it's like really super close. So hang on, let's do the flip side of that, right? That was negative 10, negative 1/10. What about positive 10? Exact same thing, but on the other side of the axis. So it's way up here this time. Oh, that board is off. Yeah. Right there. Okay, let's try, what was the next one? Negative 5 and 1/5. So negative 5, we start at the origin, we go over negative 5, which is left, and this one was 1/10, so are we a little bit farther away from the x-axis? Just a little bit farther away. It's actually almost looking like this one over here, isn't it? Negative 5 and 1/5. What about over here? 5 and 1/5, so a little bit closer. There. We're getting there. We're getting there. And what's our next one? What did we miss? Oh, 2. That's right. We missed 2. So what is it? Negative 2 and negative a half. That one's pretty easy to graph, right? Negative 2 and negative a half, right? There. Then the flip side, 2 and a half, right? There. Ooh. It's amazing how off this board gets, eh? Okay. Huh. In what way? Let me take a guess here. Do you see these patterns? They get farther away from the x-axis on the left side until they cross at negative 1, 1. Then they start going down, and then they get closer to the y-axis. What do you think this point is here, right here at the bottom? No, not 1/10. Negative 1/10 and then negative 10. Do you think that's what it is? Yeah, that makes sense because that's the flip. Now let's draw that one in. Listen, we just figured that one out kind of on our own. There we are. So what about the top part? Same at the top. It's going to be 1/10 and 10. Sorry, what? We could have put them on there, right? Doesn't matter. I'm just trying to guess points. Oh, okay. Well, do you see a distinct pattern here on the graph, though?
Yeah, it's reciprocal. It's flip.
It's flipped. What's flipped, though?
The first quadrant is flipped into the third quadrant.
No, not quite. The problem is the zeros. Okay. On our original graph, did it go through the origin?
Yeah.
It went through the origin. It went through 0, 0. Come here. Okay, let's deal with the 0, 0, please. Let's deal with the 0, 0. So in this first one, 0, 0 is that one, but if we actually do this one, it's 0 and undefined. Can you plot an undefined point? So let me ask you a question. The original goes to the origin, but does the reciprocal go through that point? There's no possible way. Oh, shoot. So how do we state that it does not go through that point?
I don't know, man. Oh, you're supposed to read the bottom?
What is it?
A line whose distance from a given curve approaches 0.
Okay. So look what's happening here. Now, look, so what it is, it's a line that approaches a point or approaches a line, right? A point that approaches the line, but never, ever touches it. It gets closer and closer and closer and closer, but never touches it. So look here. So on the left side, this curve here, what line is it approaching but never touches?
The 0.
Which is known as the x-axis. It goes back this way and approaches another line, which point? The y-axis.
Would it eventually touch 0?
No. Here's a math question for you. You take a piece of rope. You have a rope that's 1 meter long. You cut it in half. What do you have? 0.5. Can you cut that in half again? 0.25. Can you do that mathematically indefinitely?
Yeah.
Right? You just get more and more decimal places. Now, can you do that in reality? No, it gets too small, you can't actually cut it. But mathematically, can you keep cutting something in half until it just keeps going on? Will it always approach 0 but never get there? Yeah, because it's always half of something.
There's no 0.
Because there's no 0, right? It's the same concept here, right? You're taking that and you're just cutting it.
So it's kind of like teasing the line. Like it's getting closer.
Yes, it's getting closer but never, ever touches it.
Like, hey, look at me, I'm not going to touch it.
Okay. That is known as, guys, what are they known as? What are they known as? What are they known as? Asymptotes. Now, you can have two different types of asymptotes. You can have a vertical one and a horizontal one. The vertical one is for reciprocal functions. They occur at the NPV. They occur at the non-permissible values. So what could our NPV never be in this case? Because when we flipped it, we ended up with a 0 on the bottom. So it's 0. So what is our vertical asymptote in this case? It happens to be the, well, not just the origin, but in this particular, the y-axis. Okay. So what we're going to do is we're going to draw a line in here. I'm going to draw it as a red dotted line. You'll often see asymptotes drawn as dotted lines.
That was a harder way to find the NPVs.
We're not doing that. I'm trying to get you to learn about asymptotes. So I'm going to put a line right there. That is the asymptote. Now, is there a horizontal asymptote? What is it in this case? It happens to be whatever y equals b. So what is it equal in this case? So y equals x. So in this case, what is it? The x-axis in this case. The x-axis. So this one has double asymptotes, one this direction and one this direction. Now, here's the interesting thing. We can actually graph the lines in of those blue points. Right? So if you look at this, this is the standard look for a reciprocal function. It comes along the x-axis, never touching it, gets a little bit farther in, goes through this point, and starts going down closer and closer to which axis? It doesn't touch. I'm just a little off on my drawing. Okay? What about the quadrant 1? Same thing, right? My graph's off. Just leave me alone. Okay.
We understand.
So, y equal x is just a standard straight line that goes to the origin. The reciprocal of that is just the blue lines here. So if you were to draw that, right, if I asked you to draw the reciprocal of y equals x, you basically draw this. That's what you draw. That is the graph. Does that make sense? Why are they both on here? Yeah, just to show you. Remember like when we did the absolute values that we drew the original and then we did the flip?
Yeah.
Right? That's what I'm just showing you here, right? Kind of like that stuff. Okay, now, let's try an actual example. These take a little bit to understand. But once you... What? Sorry, what? Yeah, this is all grade 12 stuff. Lead into it. Okay, here we go. So there's the function, y equals 2x plus 5. You should be able to immediately graph that thing. Can you graph it?
Yeah.
So graph it on the page that's there. Graph it for me. Always graph the original. What is that, by the way? Is that a quadratic or is that a linear?
Linear.
Linear. So what do you start at to do a linear? Start at the -5, which is known as the y-intercept. Then what does the 2 mean? You go up 2 over 1. Up 2 over 1. It's plus 5. Oh, sorry, it's negative 5. It's plus 5, whatever it is. 1, 2, 3, 4, 5, right there. This goes up 2 over 1, which means you can go down 2, back 1, down 2, back 1, down 2, back 1. Did you do that? Right, you can get your points, because if you think about it, slope is the same throughout. It's like a set of stairs. Down 2, back 1, whatever you want. Okay, I'm going to draw my solid line in on this one to show the original y equals 2x plus 5. So this is y equals 2x plus 5. How's that? Is that pretty easy? You should be able to do that. We did that in grade 9 and grade 10 and grade 11. You will do it in grade 12 too. It's the same rules. They just get more difficult as you go along through the grade. Okay, now, what I want to graph is I want to graph the reciprocal of this, right? That was y equals 2x. What I want, look here, is I want the reciprocal. So I want, reciprocal. I want y equals 1 over 2x plus 5. Right? All I did was take the reciprocal and, take the original and put it over 1 and then flip it, right? Now if you look, all of a sudden, what do we have that we didn't have before? Irrational. Did we do tons of rationals already? Yes, we did. And when we do rationals, we always have to look at what? The bottom, because it tells us the NPV. Is there a number that x could never, ever be, because it would make the equation undefined? Okay, so what's the easy way to do this? You take it and set it to what? 0, so 2x plus 5. Move the 5 over, becomes negative. So 2x divided by 2. What could x never be? Negative 5 over 2. Now if you look at the graph, there, hang on. Look at the graph. We just did the work, it's right there. You need to focus 100% because you're missing stuff when you... No. Now, look at negative 5 over 2. What do you notice about that, by the way? Negative 5 over 2. What does negative 5 over 2 happen to be on this graph? Negative 5 over 2 is negative 2.5. It's the x-intercept. Does that where it crosses? Now look at that line. Does that where it crosses the x-axis? Look back at the original example. Where did that line cross the x-axis? At the origin. So what did that then become? The NPV or it becomes the asymptote. So based on that point right there, negative 2.5, what do you think that now becomes? It's an asymptote. And in this case, it's the vertical asymptote. So what I'm going to do is, right at that point, I'm going to draw a vertical dotted line to show that that's the asymptote. The graph cannot go through that point. Okay, there we go. So vertical line right through that point at negative 2.5. Because that's where it goes through the x-axis. That's the asymptote. So that right there is, here, I'll even draw it in red. X cannot be negative 5 over 2. That is our vertical asymptote. All right. Now what we've got to do is we've got to draw the rest of this graph. These graphs have a pattern, and they always have a pattern. It's either going to be, now if you look at the vertical asymptote and the x-axis, It's broken into 4 quadrants. This quadrant over to the top right, quadrant over to the top left, quadrant over to the bottom left, quadrant over to the bottom right. It's always going to be a pattern. It's either 1 and 3 or 2 and 4. So, for instance, if I draw this part of the quadrant, the reciprocal in quadrant 1 here, where's the rest of it going to be? In 3. If I had to draw it up here in 2, where's the rest of it going to be? 4. It's always that pattern. Now, you want to take a wild guess? Which quadrants do you think this one's in, based on the graph that we already have there? Wrong. It is in? Why is it a 1 and 3? Because that's where the line is. The line's already in 1 and 3, so the reciprocal is obviously going to be in 1 and 3. I'm not talking about the x and y axis quadrants. I'm talking about the asymptote and other one. Now, this is a vertical asymptote. Guys, this is a vertical asymptote. Where do you think the horizontal is? 99% of the time on the x-axis. So I'm going to draw that one in also. There is.
Why do you say 99%?
Because I'm going to show you an example where it's not. They're very rare.
Are we going to do 100 of these, or that'll be the one row?
All right, so those are our vertical and horizontal asymptotes. Now, are there any points on the graph that would be the same for the reciprocal as the original? Let's take a guess. Let's look at this one here. What's this point right here? This first one right here. What is that point? Negative 2, comma 1. So that point on the original right there is negative 2, comma 1. That's the original. Does that work for the reciprocal? Let's find out. Let's try. So this is the reciprocal. There it is. Y equals 1 over 2x plus 5. What are we replacing the x with?
2.
What are we replacing the x with? Negative 2. So 1 over 2 times negative 2 plus 5. What's negative 2 plus 2? That's right. 2 times negative 2. Negative 4 plus 5 is 1. So it's y equals 1 over 1, which is 1. So is that one the exact same point for either one? Oh. So it has to. A reciprocal has to go through that point. Doesn't it? Yes, it does. Now, look here. If it goes through this point, does it come along this asymptote and gets a little bit farther away until it crosses through that point, and then what does it do? Does it go towards the x-axis but never touches that asymptote? Yeah, it is. So draw it in.
So is it way?
Because I just picked the points to show you that those were the same. The quadrants of the asymptotes, not the quadrant of the x and y axis. The quadrants of the asymptotes. Right? You know that point. It's exactly the same point for both. Right? We just did the math there. Now, do you want to take another guess? Where do you think the next one's going to be? Do you think it's going to be the negative 3, negative 1? Well, let's try. We think it might be negative 3, negative 1. That's the original. Let's check with the reciprocal and see if it's exactly the same point. By the way, these points are really important in a sec, and I'll explain that, the 1 and negative 1. Something really fancy. Okay, we're going to check this one. So y equals 1 over 2x plus 5. But in this case, we're going to replace x with what number? Negative 3 plus 5. What's 2 times negative 3? Negative 6 plus 5 is negative 1. So y equals 1 over negative 1, which is negative 1. So is that point exactly the same on both? It is. Exactly the same on both. So where do I draw this one? Comes along. The x-axis goes through this point, 3, negative 1, and then gets closer to the vertical asymptote.
What is this negative 1? Negative.
Okay, so the black line is y equals 2x plus 5. The blue line is y equals 1 over 2x plus 5. So the black line is the original. The blue line is the reciprocal. You'll see the pattern. There's patterns after patterns after patterns. Okay. Now, if this happened to be in quadrant, and again, I'm basing it on the asymptote. If it happened to be in quadrant 2, the other one would be in quadrant 4, based on the asymptote. Yep. It leads into grade 12. Sometimes sometimes learning math is so you have the skills to go into another math. Why are you taking pre-cal in the first place? Okay, so then, because your parents want you to learn this. How about that as an answer? No, you're not going to use this in your daily lifestyle. But if you become an engineer, are you going to use this? Yes, you are. This is all stuff that leads into other stuff. Learning something just for general knowledge is a good thing. Then you go back and listen to the lesson, or you come in for extra help. Am I here for lunch today? Yes, I am. Okay, let's do the next one. Now, the next one is a little trickier. What do we got now? Uh-oh. What do we have? What's that known as? The quadratic, guys. Now, here's a question for you. A linear has one vertical asymptote. What do you think a quadratic's going to have? 2. Does normally a quadratic have 2 x-intercepts? Normally a quadratic, most of the time, will cross the x-axis in 2 spots, right? Is that true? Okay. So the only difference in this one is, instead of having 1 vertical asymptote, you're going to have 2. So how do you think we should approach this question? How did we do the last one? What did we do first? No, we don't even need to make charts. We're beyond making charts. You graph the original. Always graph the original equation. It's really easy. Y equals x squared minus 4. It's a standard parabola. What does the negative 4 do? The minus 4 do? We'll get to that. It moves in which direction? No, it's out. It's not in brackets. If it's in the brackets, it moves it left or right. This is behind it, so it moves it either up or down. Negative 4 means it moves down 4. Right? Okay. So let's graph this. So normally, don't draw this. Our normal parabola would be 1, 1, right? 2, 4, 3, 6. Is that? Well, that's not 3, 6. Right? This is our normal parabola, right? What does the negative 4 do? It takes the whole thing and shifts it down. It shifts it 4 down. Right? You should remember this. We did enough of those. Okay, so let's pick our points. So then, instead of being at 0, 0, where's the vertex? 0, negative 4. Is that correct? If I can get the line right on there. Okay. And then, what was it? It went 1, 1, so it basically moves up 1 and 1, right? Is that correct? Like, the basic pattern of a parabola is still the same. And the other one from here, the origin was 2 and 4, right? So we move over 2 and up 1, 2, 3, 4. That's kind of weird, that point there. Why is it really off on this? I hate it when my board's off. 2 and 4. What about this side? What do those points happen to be all of a sudden? The zeros or x-intercepts or answers or solutions, whatever you want. Right? Now, how do you graph this if you can't remember how to graph this? With a ruler. It's a parabola. You don't use a ruler. Table of values. Table of values, guys. So 3 and 6, 1, 2, 3, 1, 2. Not 3 and 6. What am I saying? That's 3 and 9. Oh my goodness. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? There. And there. Okay. Do you see it? You see the parabola? Can we draw it in now? Yeah. Try to draw it as smooth as you can. Sometimes it's... What? Well, 3 squared is 9, minus 4 is 5. Stop whistling, please. Okay. There is our lovely little parabola. Y equals x squared minus 4. Do you see it? Now, not stupid. What do you think? Well, first off, where does it cross the x-axis? Negative 2 and positive 2. So look at this for a sec, guys. I want to show you something. So let's talk about NPVs for a sec. Let's talk about the reciprocal. What's the reciprocal of this? Look, what's the reciprocal of that? 1 over x squared minus 4. Okay, now, basically what we want to know is, we want to know what the NPVs are, so we can't have 0 on the bottom. So we can't have 0 on the bottom. So 0 can't equal the bottom. Now, what do you notice about this? You said this, somebody said this before. It's the difference of squares, right? So 0 equals x plus 2, x minus 2. So what can x not be? Plus or minus 2, because those are NPVs. And you also notice those are the...
Why did we get rid of the 1 on the top?
Because we're just doing the math. We're just finding what the NPVs are. When we found the NPVs, did we care what was on the top? Ever? No, I'm just doing the bottom because I'm just solving for NPVs. Okay, now, that tells us that the graph, our reciprocal, could never, ever go through those 2 points. So what do those 2 points now become? What kind? Vertical asymptotes. They are the lines that the graph can never touch. It. So what do we do then? We just take them in, draw them in. Okay, just let me move these over a bit just so they're... Whoa! My whole graph moved. This board is just ridiculous from this. Oh, did it shift over again? Oh, shoot. Hang on. Thank you. All right. Wow. Okay. So that becomes vertical asymptotes. It could never, ever touch those points. Is that correct? Now, hey, you want to take a wild guess at what the horizontal asymptote is? The x-axis, right? 99% of the time, right? Yeah. You'll find out. I'll show you. Actually, I don't even know if, do we hit that in grade 11? That might be grade 12 where we move the... No, you don't have a clue. Okay. You don't even know who he is. Okay, now look at this. This is weird. Because in here there is a pattern. You have to decide where it's going to be. It's one of 2 options. Okay? It's either, I'll just write this to the side, just so you can, just so you can see this. I'll write it to the side. You don't need to write this. Well, you can if you want. I guess you can if you want.
You should write it.
This is what it's going to look like. Here's your x and y axis. Here's your x and y axis. I'm going to put in some asymptotes. There's one and there's one. There's one and there's one. The pattern is either going to be one of 2 ways. It's either going to be this, this, and this. Right? It's going to look like that. Or it's going to look like this. That's kind of crazy. It's either going to look like this, this, or this. Okay? So the problem is either going to be in the bottom with the 2 other pieces in the top, or the problem is going to be in the top with the 2 other pieces in the bottom. That's the only what you're going to see for now. That will change later on, but that's the basic rule. It's either going to look like one of those 2 options. What do you want?
Let me get, it depends on if it's a amount max or value.
It has something to do with it, but we need some better points here. What?
Is there ever going to be, like,
Where it's all on the top or on the bottom? Yeah, I just said that.
that was really good question. Is there ever going to be, like, 2 or 4 or something? Or is it
Well, you're going to get the cubics, but we'll see about that. Don't worry about that right now. Okay. So now all we got to decide is where this is going to go. It's either going to be in the top 2 left in the middle, or in the top, middle, and either the 2 bottom left and right. Shoot. So what we need to find is we need to find points that are exactly the same for both graphs. Wouldn't that help us? Yes, it would. Okay, we're going to do one other thing first before we do that. Now, here's the deal. This is kind of cool. Look at this one for a second. What's this point right down here at the bottom? 0, comma, negative 4. Okay. What is the reciprocal of negative 4?
4.
Wrong. That's the
1 over negative 4.
That's the opposite of negative 4.
1 over negative 4.
1 over negative 4. Okay, so we have negative 4. Right? So our original graph, right, the y-intercept was 0, comma, negative 4, right? We're going to do this one in blue. So what is the y-intercept of the reciprocal? Reciprocal. 0, comma, what's the reciprocal of negative 4? Negative a quarter. Oh, well, isn't that a useful point to know? So where would that be on the graph? 0, comma, negative a quarter. Okay, so we know, whoa, that graph is right off. There it is there. Now, it should give you a dead giveaway what this graph's going to look like. Where's the problem going to be? Which one of these is it? Is the bottom? It's the second one, right? The problem is going to be in the bottom. The reciprocals are going to be in the top left and right. Okay? We know right away. Oh, well, that was useful to find out, wasn't it? Okay. Now, if you're unsure, I'm going to show you another thing. There are the points. Now, make sure this is clear, please. You need to pay attention to this. These are the points that are exactly the same on the original as they are on the reciprocal. Right? Did we have that on the first linear graph? Didn't we have a point that was exactly the same? Remember it was, what was it, negative 1, negative 2, and negative 3, negative 1? Is that what it was? Something like that. We can go back and look. Now, these points have a special name. They are called invariant points.
Where do all these words come from?
Okay, this is easy. It's really, really quite easy. The invariant points are the points that are exactly the same on both the original and the reciprocal. Right? So if I figure out what these points are, I can plot them in black for the original, and I can plot them in blue for the reciprocal. Is that right?
Yeah.
Okay. And we already know what the original looks like, don't we? Because we drew it on the graph. Okay. Now here's how you figure it out. The key to solving the invariant points is to make y equal to plus or minus 1. Okay. So y could be 1, or y could be negative 1. Because that's the same point. You'll see in a minute. Okay. Now here's the question for you. I said the invariant points are exactly the same on the original, the y equals x squared minus 4, and the same as the reciprocal, y equals 1 over x squared minus 4. Now, there's two equations there. Which one do you want to do?
Easier one.
Which is the easier one? The first one or the second one? The first one. First one's easy, isn't it? Yeah?
Easier.
Could you do the second one if you wanted to? Sure, why? You'll get the exact same values because they're the exact same points on either equation. But pick the easier one. Okay. So what's the easy equation? X squared minus 4, right? What do we want one of them to equal? 1? What do we want the other one to equal? Negative 1. There it is. Now, can we do some math? These are the same. It's just part of the same chapter. We graph absolute value. We graph reciprocal. No. It's the same. Some of the same rules that you're following when you graph stuff are the same.
We have two different tests for this, or
All one test. There's multiple questions. Well, no. If it has an absolute sign around it, you do that one. If it says reciprocal, you do the flip. Okay, let's solve this. What do you do? X squared equals 5. What do you do then? Take the Square root of both sides, what does x equal? Careful, what does x equal? Plus or minus square root of 5. Thank you very much. We're dealing with parabolas here. We have a plus and minus there. Move this one over, the negative 4 over. What does it become? X squared equals 3. Take the square root. What do we end up with? X equals plus or minus root of 3. Okay, now, so when y is 1, what could x be? Plus or minus 5. If y is negative 1, what could x be? Plus or minus 3. Now, if you need points to plot, do you need an x and a y value? Okay, so what we're going to have is let's figure out our x and y values. Here they are. Here's one set. Here's another set. This does not mean multiplication between them because, here, let me put commas between them. Okay. What is x in this first one? What are the x values in this first set here, right here? So one is plus 5 and one is negative 5. And what are both the y values for this? 1. So we now have a set of points we can plot. And what's the cool thing about those points right there? They're exactly the same for these points here. They're exactly the same as the original as they are as the reciprocal. What about the next one? What's x in this case? Plus 3 or minus 3? Woo! Minus root of 3. And what, hey, look, what are the y values? Negative 1. Oh, okay. What?
What do you think that invariant
Invariant points. You make y equal to positive or negative 1. There's points that are the same on the original as they are on the reciprocal. Write that down. Write that down. They're the same points.
Why choose that?
Because that's what the formula is. You don't have to worry about that. We're not going to solve the formula. I'm just telling you what they are. Okay. Well, you want the easy explanation? This is the easy explanation of why it's the same. Watch. What do you notice there? What do you notice there? So 1 and negative 1, are they exact the same as the original as the reciprocal? Yeah. We're not going to do the proof for that. That's in university. And you just have to know that. You just have to accept that, basically. Okay. Okay, now we got, those are a little tough to graph, aren't they? Guys, but do we know what this graph already looks like? It's going to be, it's going to be up here, right on the top right. It's going to be between these 2 points in the bottom here, and it's going to be on the top left. That's what it's going to look like. So let's see what these points look like. Let's try to find them. Where is negative, let's do root of 5 comma 1. Let's try that one. What's root of 5? Actually, go to the calculator and do root of 5 for me. 2 point what? 2.2. Okay. So it's a little bit bigger, guys. It's a little bit bigger than the vertical asymptote. And then it said 1, right? So what do you think the point is? You think it's right there? Root of 5 comma 1. Oh, sorry. Root of 5 comma 1 right there. So I'm going to do this in blue. So is that root of 5 comma 1 right about there, do you think? It has to be on that line, doesn't it? Why does it have to be on that line? It's the same point for the original and the reciprocal. Okay. Well, that one was easy. What about negative root of 5 comma 1? Where do you think it is? Yeah, negative 2.2 comma 1. So probably about right there. Is that correct? Yeah? The thing is, when you sketch your reciprocals, you're really sketching them in, right? Because you're trying to draw that line. If you saw when I drew it before, it kind of wavered a bit, right? I didn't do it very smooth. But you know for certain, does it go through those 2 blue points at the top there? It does. So I'm going to draw those in. Here we go. Oh boy, here we go. It's going to come through this point, and then it's going to go this way across that axis. Okay? And the other one is going to go, here, I'm going to go backwards on this one. This might be easier. It's going to go through this point across here, come through that invariant point, and go up that way. Now, when you sketch this, is it a good idea to graph these points on there, like actually tell me what they are? Yeah, that's usually a good idea. So the invariant point here was root of 5, comma 1, and the invariant point here is negative root of 5, comma 1. What?
Right.
Yeah, no, don't. Do it always as the original, right, because it's more accurate. Root of 5 is better than 2.2. Right? Because it's the point that's exactly the same. Look at the black line is the original, the blue line is the reciprocal. It's the point that's exactly the same on both graphs. Yeah, you just plug it in your calculator, right? 2.2.
Why would you think this one is the root of 3 and 1 and negative root of 3 and 1?
We're doing that one. We're getting to that one right now. Okay, so that's root of 5, comma 1, root of 5, comma, or negative root of 5, comma 1. We're still missing, look, we're still missing what? Root of 3, negative 1, negative root of 3, negative 1. Now, we know that because they're negatives, are they below the x-axis? Okay, now, what's root of 3? 1.7, what is it? 1? Well, you need to. We need to know what the point is.
1.7.
Okay, so 1.7. Okay, now look. The asymptote is at 2, so where's 1.7? Just to the left of it, and it's negative 1. Is that the point right there? Oh yeah, there it is right there. Now, if you've done it pretty accurate, you'll probably nail it almost dead on, accuracy-wise. So that one, where's the other one over here? Well, negative 1.7, comma, negative 1, so right there. Okay, now, what does this one look like? Blake, turn around, please. Look at this. It's a parabola, but if you look, kind of flattens out at the top. Does it have to go through all three of those points? It has to go through the invariant points, but what's this other blue dot here? What is that again? That's the y-intercept, or the vertex of that piece on the reciprocal. All right, try to draw this one in. Oh boy. There we go. Whoa, that's way off. Whoa! Nice graph, eh? Okay. Okay. So the original was the black one. I know, but you do it with different colors if you need to. You get some different colored pencils or pens, and you do it with different colors.
So the little lines always go along the
Asymptotes. They go along it, but never, ever touch it. Right? Think of it as an electrified fence. You could run along the electrical fence for as long as you want, but do you touch it?
No.
No.
Never.
Ever.
It's scary.
It's scary. Like, the asymptotes are scary. You never, ever touch them. You're missing the point again. Okay, so what we'll do is, there's one last one, and we'll do this one tomorrow, because this is kind of like, could you just listen for a sec? This is a backwards question. I actually give you the graph, don't I? Yeah, I give you the asymptote, and we have to figure out what it is. So we'll do this one tomorrow. What I would recommend, if you got a few minutes before the end of class, I would try to start some of these questions. The key is you really have to understand this. You have to be able to graph the original flawlessly so that it'll help you graph the reciprocal. It's basic rules, right? Here's the rules. If you have a linear equation, where it crosses the x-axis now becomes your asymptote. It has a square or it doesn't in it. It has a square in it, it's quadratic. If it's a quadratic, you're probably going to have how many asymptotes? 2. And 99% of the time, where's the horizontal asymptote going to be? X-axis. Okay, you got that? We'll finish the rest of this lesson tomorrow.